Hello, everybody. So my name is Aris Manassakis. I'm a co-founder and chief operating officer of company Procureship. So for those of you who do not know us, we are an e-procurement platform. We optimize the way RFQs, quotation, purchase orders interact with the established ERP of the shipping companies. We also offer a marketplace of suppliers and service providers and a recommendation algorithm which proposes the most suitable supplier for each RFQ. And we have also optimized further akin parts of the external communication with the suppliers, such as the invoicing, the service providers marketplace, IHM, freight forwarding, and managing contracts electronically. We use machine learning, NLP classification, and other AI technologies extensively. I will showcase exactly how we do that. A few things about our company. We are a strictly technological company. We are 50 people. We have offices in Athens, where our headquarters lie, in Copenhagen and Singapore, and more than 40% of our workforce is in-house software engineers. So our key strength is that we develop everything internally using cutting-edge technology, and we like to keep it this way, despite our rapid growth. Our systems have been thoroughly used. We have now more than 85 integrated shipping companies that amount to more than 2,000 vessels, and more than 8,500 connected suppliers. So here are a few cases which I'll break down for you, where we use artificial intelligence and other relevant tools. First, I'll show how we do this in our e-invoicing feature, where we automatically map invoice items with delivery order items. Then I'll explain how we use it for our auto-recommendation of relevant suppliers and our recommendation algorithm. Then in the forecasting quotation delays, so we're able to automatically send reminders when we know that we're anticipating a quotation from a supplier. Fourthly, in a services marketplace, in order to categorize the relevant service orders. And also in the vendor and brand mapping process, so these are some back-end procedures we need to perform internally so that our tools can work efficiently. So the invoicing. So what this module does is that it optimizes the way that the invoices are automatically collected from thousands of suppliers worldwide. Invoice items are automatically mapped with relevant order delivery items in a header level, but also line-by-line item. And then invoices, together with the attachments and all the items, are automatically imported in the accounting software of shipping companies. We have done this test again and again. It optimizes the process by more than 60%. So if you time the process you need to perform the invoice checking procedure in a shipping company without such a tool, and then you try to time it compared to using Procureship, you'll see how much time and cost you're saving based on this procedure. Now, the AI that we perform in this case is that we have trained our own machine learning model, which we have fed with thousands of hundreds of invoices from any type of industry in order to help it self-educate and be able to read invoice items on an invoice items level. And right now, we're able to identify automatically more than 80% of invoice items and map them with the relevant delivery order items. So on top of the machine learning model, we have created an automatic parsing mechanism. So it's a similarity algorithm that automatically parses the invoice items with the delivery order items. This small NLP system, let's call it, uses multiple variables and labeled data, and it improves over time its accuracy since more data is fed from within the system. And I'm showing here a slide where you can see an actual example. So this is what the end user will see. They will see the delivery order on the left-hand side. On the right-hand side, you see an invoice, and you see that we mark automatically with green the invoice items that were found correctly with the same unit cost, same price, same line cost. We mark with yellow if they were found with discrepancy, and we mark with red if it was not found at all. Another aspect of our business is the data processing that we perform on our backend. So in terms for us to be able to provide all the tools we provide to our clients, we need to perform a thorough data cleaning procedure. So you have the input of the data, which is the thousands of item descriptions, thousands of vendor names, of vessel names, of order details, of invoices, of quotation details that come into our system. Then we perform advanced text similarity, automatic and also manual mapping of all this data with our own internal unique Procureship codes. Then we perform some outlier detection, within which we utilize machine learning models in order to identify which are outlier items. And then we are able to analyze these items using classification and NLP in order to provide the output. Now the output based on this data processing process could either be the recommendation engine, which I'll show right away, or the real-time data insights. So on the spot, while the user is performing their daily work, we can notify them that there is an outlier case or that there is a discrepancy that they need to look after for, and of course, the relevant reports. Let's see the recommendation engine. So here what we do is we leverage all the trading history, anonymously of course, from all the shipping companies that use our system, and we try to promote or recommend the most suitable vendors for each RFQ. So when an RFQ comes, based on the relevant features like the port, the type of the items, the maker of the products, the brand if it's a spare part, we're able to recommend what we believe are the most suitable suppliers. The recommendation algorithm on the back end poses some qualitative type of questions. So for instance, if a supplier is repetitively being selected for the said items by different shipping companies from different countries around the world, and they trust him with repetitive orders during the last time period, then this could help them be ranked higher in the recommendation engine. On top of that, we use collaborative filtering in order to see the win ratios and showcase who are the most probable suppliers that would be suitable for the RFQ case of the shipping company. Now, where the ML, machine learning, comes into place in this case is that on top of that, we have an algorithm, a machine learning algorithm, that uses a statistical model to automatically assign a relevance score for unselected suppliers. So what the ML will do, the collaborative filtering mechanism will show the recommended suppliers, the user will select, and then the ML will auto-recommend some suppliers that have been omitted from the case. And we've seen that many times when this takes place and the user actually selects also the auto-recommended suppliers, they end up getting the order, meaning it was a good selection and a good recommendation from our ML model. Another part of the process is forecasting the quotation time. So when you send the RFQs, we have developed an ML statistical model which is able to forecast when the suppliers will reply to a quotation based on their specific statistical mean. So this gives us the ability to be able to send automatic reminders to RFQ cases that have not been quoted in the projected response time. Another module of ours, where we use LLMs in this case, is the services marketplace. So the problem we have to solve here is that the services orders are not as commoditized as the items orders. So you can imagine that the items, stores items, the spare parts, the chemicals, the paints, you have more standardized type of items. You can use the part number, the IMPA code, relevant labels in order to be able to perform your recommendation actions. Now the services, you have the raw data is more unstructured text because the type, usually the users will just type a text of what is the service they're looking for, and then they will send the order. So what we did in order to solve the problem and create a good marketplace for service providers is we gathered all the raw data from as many shipping companies as we could. So we actually gathered more than tens of thousands of different service orders from the ERP systems of the shipping companies. And then we created our own services categorization tree, which amounted to roughly 150 categories and subcategories. Then we used LLMs, which we trained, in order to map all the past services orders with our categorization tree. This happened on our backend. The end experience for the user in this case is that a person from the technical department can type any type of services that will come in mind and will be able to provide accurate results based on a categorization tree. Another feature where we employ generative AI in this case, we integrate with generative AI models, is when we perform our vendor and brand mapping process. So when we onboard a new shipping company, a problem we have to tackle is that you have the vendors of the existing vendors of the shipping company. On average, a shipping company will have 100 to 800 active vendors, and we as Procureship have more than 8,500 active suppliers. So you need to map the hundreds of different vendors as they appear in their system with your own Procureship suppliers. In order to solve this issue, we have integrated with generative AI models that assist us in automatically mapping the different vendor names based not only on the vendor name, but of course we label any data such as the email, the address, the telephone, with our own Procureship unique supplier IDs. Equivalently, we perform this on the brand mapping. So the brand mapping is the problem that you're trying to solve is the fact that in the PMS systems of shipping companies, many times you have the maker or the part number written in different ways or in wrong formats. So I'm showing here an example where you can see the external brand name of Yanmar as it comes from the PMS with different letters in some cases or some special characters. And we have our own unique Yanmar labeled brand name. So here we employ the generative AI in order to be able to automatically map the different Yanmar codes as they come from the different PMS of shipping companies with our own unique brand name. Now, a very important slide I want to highlight, and this is our approach when it comes to artificial intelligence, is that you need to balance artificial intelligence with human intervention. Although we do employ a lot of cutting-edge AI technologies and a lot of aspects in this regard, we do not believe that all processes should be powered solely by artificial intelligence. A very good example in our case is our live chat support function. So you can ask any of our clients worldwide, they have repetitively ranked with very high marks our support channel. This is a live chat where the user can come with any type of business request, not just technical support, and request assistance on the spot. We do not employ strategically a chatbot in this case, but we have actual trained account managers that are aware of the specific shipping company and its users and will assist on the problem. The reason being is that the business problems that the users come with us are more complex. So when a user will tell us, I have to leave the office, I have to go back to my family, it's getting late, I have these quotes from Santos, Brazil, and I need to get them as fast as possible until tomorrow morning. Please make sure I get them. This is a business example that the actual trained human person can resolve much better than any artificial intelligence model. And last, I'm showing you here an overview of indicative integrated shipping companies and suppliers that we have. And I want to point out that in the integrated suppliers space, it's also important for us to assist them on their side using artificial intelligence on how they quote. So there, what we do is we offer complete integration of our system. So large suppliers like MAN, Wärtsilä, Wilhelmsen, RMS, and so on, they do a complete integration of their ERPs with our system so they can quote efficiently and save time. For smaller companies that we wanted to assist, but they could not integrate with us, we needed to find a solution. Because we firmly believe that if you don't have the suppliers as happy as the shipping companies, you cannot provide an efficient procurement platform in the end of the day. This is why we created what we call the easy integration. So there, we use an OCR AI trained model, meaning that the suppliers can upload their own quotation forms, and our AI OCR is able to read and parse the quotation items and automatically fill the RFQs. Thanks to this, the suppliers can easily quote, and then the buyers can have the advantage of getting all their quotation for all their flow for any type of items automatically imported and evaluated inside their ERP. That's it from me. Thank you very much.